Hey, Seattle Prep, AB Calculus. This is Mr. Ellinger here, and my Surface is kind of on its way to being set up the way I want it to, and I think we're going to be able to record this video without any glitches. Fingers crossed. But it's a little bit in between, so I have to be on this kind of lousy version of OneNote, and I can't boost my page or anything. I'm going to go over the answers to the pre-calculus review pages. I'm going to focus on a couple of the I think the trickier ones, or the ones that I think you're more likely to have forgotten, or the ones that I think are more important for calculus. So some of them I'm just going to gloss over, and some of them I'll go into some depth. Okay, here we go. So first one. F of 2 equals G of 2, so you can plug 2 into that, you can plug 2 into that, set them equal to each other, and you figure out what K is. Second one is an important one. So I've done part of the problem to save myself some time, but I stopped there. So this is solving a polynomial inequality. We're going to be seeing a lot of these this year, a lot more than you saw in any like algebra trig class, definitely, and also more than we did in pre-calculus, although you did this in pre-calculus, so you would have run into it, but it would have been like in chapter 2 or something like that, so I could totally understand you forgetting it. Okay, so we're solving the inequality, and I did typical equation stuff here, but I've stopped at this point. And the tricky part is we can't just set each one of these less than 0, because if you think about it, if this thing was less than 0 and this thing was less than 0, then that would mean when you multiplied everything together, you'd get a positive number, which means the product would not be less than 0. So you can't do the usual zero product property thing where you say, oh, if these things multiplied together equals 0, then either that one's 0 or that one's 0. That works great for equations. Inequalities are different. So there's 2 ways the book showed how to do this problem. I'm going to show you both in this one. So, all right, what do we know? Well, we know that if you plug in x equal to 2 or x equal to -1, then it's equal to 0, so that's not a solution because we want strictly less than. So I made a little number line over here, and I'm going to mark that as not a solution and not a solution. And what you learned back in chapter 2 of pre-cal was that what those zeros do is they divide all the possible numbers into 3 sections, this section, this section, and this section, and all the numbers within those sections will either be solutions or not be solutions. So you just have to figure out which regions are the solution regions. And the way the book taught it was the book said, well, just plug in a number from out here. So you could say, let me try a number like, -3 and see what that does. So you go, all right, -3. So 6 and -3, -3 minus 2, -5, and -3 plus 1, -2. So I got -2 times -5. Ooh, that's 10 times 6. Whoa, that's 60. That's a big number. That seems like a really big number, so I'm wondering if I, am still getting back into gear here, but I think I did that right. Okay. And so, yeah, it looks good to me. So that's not a solution because I'm getting a big positive number, and I want the product of all this stuff to be less than 0. So the numbers I'm getting here are positive. I'm just going to put a little positive right there. And then you'd pick another number in the middle region and see if that area is a solution. And then you'd pick a number over here and see if that's a solution. And that'll tell you what's happening in that whole region. Okay, but in my class, I don't know if you did this in your class, but in my class, we did it a different way because this is a parabola. Like if you graph this thing on a 2-dimensional graph, I'm making a x-axis here, you'd know what shape that was. This is an x-squared graph. This is a parabola. It's 6x squared, so it opens up. So we know just by looking at this, I hate this version of OneNote, but that's kind of handy. We know that the graph of this thing looks like this. So, well, wait, it's up above over here. So I knew that the numbers over here must have given me positive answers because it's up above the x-axis. So anything less than -1 gives you a positive answer, and they're not solutions. Everything between -1 and 2, according to this graph, this opening up parabola graph, everything between -1 and 2 must give you an answer that's less than 0. So this area, all the numbers are negative. And in the right-hand region, it's up above the x-axis again, so all the numbers are positive. Plug in a number, plug in 5, I don't know, plug in 10, whatever you want to, you're going to get a positive answer. We want when this product gives you an answer that's less than 0, so that's just in the region in between. And so the answer is everything from -1 to 2, not counting -1 and 2. I'm using interval notation there. All right, so that's, if you know what the graph of this thing looks like, then you can often figure out the regions just by knowing the graph rather than plugging in numbers and hoping you don't make a numerical mistake by accident. If I didn't know this graph, then plugging in the numbers would have worked just fine. It's just a little more tedious, and with graphs, it's let's do it the efficient way. All right, that's the answer to that one. There's another example like it later on because, like I said, it's a really important one. What time are we at? 6 minutes. Doing good. Okay. All right. Given the figure below, I just made a quick note here. The horizontal asymptote, you look at the powers. Since the power of the numerator, the degree of the numerator, degree of the denominator is the same, they're both squared, x squared graphs, x squared polynomials, then you look at the ratio of the coefficients. So it would be a to 1. That's just for reference there. Whoa, that was kind of weird. Can I do that again? Whoa, freaky. I don't know why it's doing that, but I'll move on with my life. All right, but the horizontal asymptote is kind of weird here because I see on one side it says -3, on the other side it says +3. Which one's a horizontal asymptote? Kind of confused. So let's go to the vertical asymptote. I just thought I'd review that. You don't actually need to look at the horizontal asymptote to do this problem. Vertical asymptote is when the denominator is equal to 0. The denominator is x squared plus b, so that's got to be equal to 0. And I can see I've got a vertical asymptote at 2. So this thing, this denominator has to be 0 when x is equal to 2. So I go 2 squared. Woo, it's doing that freaky thing. I've seen it do that before, and it bugs me when it does that. You got 2. Oh, okay. Squared plus b has to give you 0, and so therefore b is equal to -4, and there's only one that gave you that option. Yay! If there was another one with b -4 and like you had a equal to -3 or something, then you might not be clear about which one was the correct option. But the choices they gave you here were clear. Next one, I just want to make a brief shout out for point slope form. You might think, well, that's a silly thing to be a fan of. Point slope is going to be a lifesaver in this class at times, and you really want to get in the habit of using point slope. I'll explain why later on. This problem doesn't do it. So how do you use point slope? You plug in the slope where the slope goes. It says f of 1 equals 4, so that means when x is 1, then the y is 4. So when y minus 4 equals 3 times x minus 1. And that's the equation of this line that they're asking about in number 4. They want f of 1.2, so that's what's the y when x is 1.2. So you can plug in 1.2 in for y. And a cool little thing about AP Calculus that I'll teach you right now is that you don't have to show every single step. You should show the setup, and then you can do algebra in your head or computations in your head and then show the answer. I'll teach you over the course of the year how much work you need to show. So 1.2 minus 1 is 0.2 times 3 is 0.6, and then add the 4 over. I can just put an arrow and say y is equal to 4.6, and that's the answer. So I showed really clearly what equation I was solving, and then I showed the answer, and that's good enough. I'm going to pause it and get ready for the next page. Ooh, and actually, before I do it, number 6 is just like the problem we did before, where you're solving an inequality. You're basically solving this inequality being greater than 0. So if you didn't really get very far on problem number 2, you should try it now. Can you make a number line, divide it up into regions using the zeros, and then decide which regions are solutions and which regions aren't, and do it whatever way works for you. So now you should pause this so you can do it yourself. Okay, Mr. Allinger here. Time for answers. And here's my graph. Because x minus 2 is the first power, it just passes through. Because x minus 3 is the second power, it does a little mini parabola because it's squared. And because x minus 4 is the third power, it does a little mini cubic. I want to know when it's greater than 0. That would be from... Sorry about that. That'd be from... I know. Alarming situation. No, I'm just kidding. From negative infinity to 2 union 4 to infinity. I solved 7. Not going to talk about it. 8. Big thing was, do you know what natural log values? When is natural log positive? When is it negative and stuff? So if x is greater than 1, then natural log of x gives you positive answers. This is what a natural log x graph looks like. It goes down towards infinity. And so if x is greater than 1, then natural log x is going to give you a positive answer. So therefore, this thing is going to be a positive. Positive divided by positive, and it's going to be positive. Separate question, if x is bigger than e. So if x is bigger than e, natural log goes through e comma 1. Then natural log x is going to be a number bigger than 1. Yeah. And so, therefore, 1 minus natural log of x is going to be a negative number because it's going to be 1 minus something bigger than 1 divided by a positive. It's going to be negative. Next one is just a reminder that your pre-cal teacher wasn't kidding. You need to know what the cosine of pi is and the cosine of 0 and all those things. If you don't have it on your calculator, I can pass on the TrigPrac program. There we go, the TrigPrac program that I give to my pre-cal students, that gives you problems like that, and then you type in the answer, and then it tells you if you're right or not, so you can do that. So anyway, cosine pi is -1, so this is 4 minus 1/2, minus 1/2 times -1 minus 1, so that's that's -2, that's -1, minus plus. So I think that's 5. Doing it fast, running out of time. This one, I've got the answers there. Do I need to say anything? When does this thing change signs? Only at x equals -2, because it's got 2 zeros. It's got a 0 at -2 and a 0 at 0, and based on the factoring. And the x squared one is a turnaround. It doesn't pass through, so that does that. I'm just going to leave the answer here because I think I can actually finish this video. Horizontal asymptote, I just imagined it multiplied out. The powers are the same, so it'd be -12x squared with other stuff over 4x squared, so it's -3. I solved this one. I didn't quite finish it. Divide by 2 pi. Did I do that right? Okay, so -1. So the cosine of 2 pi t is -1. That means 2 pi t has to be pi, and then technically it could have some revolutions. If you ignored this part, that's okay. Divide by 2 pi, and you get t is equal to 1/2, I think. And finally, last one, solving that one using a calculator. I've got it all loaded up. What I did was I graphed the left-hand side. Yeah. And I graph the right-hand side. I always like to start with zoom decimal. And it looks like it has 2 solutions. So the function on the left gives me an answer of 1/2 at this value and at this value, and I could find them. I only got a minute by using the intersection button on my calculator. So you need to be able to do this. So if you haven't, so one answer is x equals -1.678. And I'll let you know that we round to 3 decimal places in this class. So -1.678. And the other intercept, do I have enough time? Yeah, I got 45 seconds. I can do it. The other one is about there. And it looks like x equals 0.768. They're not exactly that, but they're close to that, so good enough. So I just graphed both functions and then found out when they give the same value and reported those x values. Okay, I finished before 15 minutes are up. Don't know if I'll have the second video for the other one, but I'll at least have an answer key posted so that you can check your answers. I think that's it. Have a wonderful rest of the week, and I'll see you Friday or Monday.